Howdy, we are on section 2.6 and we're looking at functions and doing operations with them, either adding, subtracting, multiplying, or dividing, as well as composite functions. And here you can see we are adding these two functions, so we simply have them here. I have them separated in red and blue. And since there are no like terms, then that is our final solution. And this next one, we're multiplying them. And so since we have two binomials here, we do have to FOIL. And so we see that work here. We don't have any like terms to collect once again, and therefore we just put them in descending order so that we have our highest exponent first. Here's our first look at a composite. So this is f of g of -7, which is another way of saying we're going to evaluate the function g with -7 first, as you can see here in blue, to get a number. And then we're going to evaluate that with respect to f, that function, so plugging that in here. So I kind of have f in red on the outside, blue on the inside for g of x, and you can see once we get to this point, we're just evaluating to get -163. Here we can see we're adding these expressions or functions after we've evaluated by putting 2 in for them. So we can see here the functions are adding. Here we are simply putting in and evaluating the given value of 2 to find 8. Next, we're multiplying, and we're evaluating x at -2. So you can see here the two functions. I'm evaluating them at -2, and then at the end I am multiplying as stated here. In this next one, I am dividing these, also evaluating where x is 5. So you can see here I have the red function on top and the blue one on the bottom. I am evaluating at 5, and then just simplify your fraction. In this next one, you can see we are subtracting here, so be careful and make sure that you distribute this. But since we are evaluating at a number, we can just go ahead and get that down to here. So there's no need to distribute this if you don't have to. We can just evaluate to get 17 and we just subtract. And here we're evaluating here, so we square first to get 9, multiply to get 45, add to get 49, and 32 is our final solution. In this next problem, we're doing all of the above. So we're looking at adding, subtracting, multiplying, dividing, and we're doing composites in both of those sequences. So here we do that here, collecting like terms. Make sure you distribute that negative as you see here, then collect like terms. Here we have to FOIL, and then we collect these inner terms. Here we're dividing, and we can't do any simplification. And here we are simply distributing and then adding like terms. And so then we're looking at domain. And so for all of these, our domain is going to be from -infinity to infinity for our domains, except for ones at which we have some type of constraint on it. So this one, domain is simply asking what x's are we allowed to plug in. As you can see in all of those, it's there. Here we have an issue, right? We can't divide by 0 in math, so we have to say, well, what value, if I plug it in, will I get 0 on the bottom? And that's simply the value that won't be allowed to be in our domain. So when we solve this, we see that if we plug in that value, we get a 0 on the bottom, so therefore our domain is everything but that number. So it goes, and we use parentheses because we can't include that number. And this is a U for a union between those. So this is a long way of saying all numbers except 5/2. And then for E, we go back and we're just using all real numbers. And same thing for F here, all real numbers. We'll be doing a lot of things concerning domain, but simply it's, well, we're trying to find or be detectives in what X values can we not plug in. So the only one we had to worry about was D when we're dividing, because we simply can't divide by 0. And then in other instances are going to be, we're not being able to take the square root of a negative number is also a very popular one. So next one, And so when we're looking at this, as you look in A, we're looking and we're using the graph. So in other problems, we could plug in -2 and see what it equaled, but we have to just go and look at this graph. So I have F is your blue graph, and so it says when X is -2. So I simply go to X where it is -2, and I go, all right, what is the value on the blue graph? So I go up, and the value I see is 4. So that's where I get this 4 from. I go to -2 on the X, up to 4, and then I know that equals 4. I do the same with G. I go to -2, and then I see, I don't have a fuchsia color, but I do have red. And so I say, what is the value on the fuchsia? And I see it is exactly right here. So the Y value here is 0. So that's where I get this 0. And then this tells me for A to add those values. So 4 plus 0 is 4. Same thing for B. We were just looking at 1, so I go to 1. And I said, what is my Y value on the blue graph, or f of x? And I see it is also 1, so that's where this comes from. This tells me to subtract. So I go to 1 here, and I am subtracting -3 here. So that's where I get this -3. 1 minus a -3 is the same as 1 plus 3 to get 4. Looking at C, we're going to be multiplying our values. So I look at what is happening at 0, and on the blue graph, I am also at 0. I go to G of 0, and I get -2. And then when I multiply 0 times -2, I get 0. And then we're dividing these, and we're looking at +1. I get 1. That's where this comes from. And then G of 1, I go down, is -3, and that is my final solution. Same type of process here. We're given the x value, and we're trying to find the y on each of the separate graphs. So, excuse me, at 0 here for f, I go to 0. For my x, I go down here. This is -2. That's where that comes from. Same here. And then on the red graph, I am at 1. That's where this comes from. And I simply add those together. Here, my x value is 1. I go to 1. What am I on the blue graph? I am at -3. That's where this comes from. I am subtracting my value here. I am at 1. I am at 0 for my y on that particular graph. And when I combine those, I get -3. Following this one, I'll be multiplying. So I go to -1 for my x. What am I on my blue? I go down. I am at -3. I am at 0 for the red graph. And when I multiply that, I get 0. And then we're dividing. When I'm at 0, I get -2 for the blue. I get +1 for the red. And when I simplify that, I get -2. More of the same, except instead of adding, subtracting, multiplying, dividing, here we're looking at these functions here are functions within functions, or composite functions. And so here we're going to be evaluating. So when you see this format here, this lets us know that we're going to be evaluating with G first. So that's what happens here in red. So I go to my x value, and I say, what is my y value of the red graph? It is 0. So that's where this comes from. Now that becomes your x value for your f. So now it's saying, what is my y value when x is 0? So I go to 0, and I'm looking at the blue graph now, and I go up, and I see it is at -5. I'm sorry, +5. And then B, we're going to follow that same format, except you see here, we're evaluating f first, and I've written it a little bit differently. Same as up here, or we have this like slight little circle in here that we have. And so here, my x value is 5. I go to 5. And I'm like, what is the value on the blue graph? It is 0, so that's where I get this 0 from. Now, that 0 becomes an x value. I go to 0, and I say, what is the value on the y for the red? And I get -8. So that's where this comes from. Here, we're looking at just f of -3. So I look at -3, so I go over to -3, and I was like, what is the value of the y on the blue graph? So I go up to it, and I get 8. That's where this comes from. Now that 8 becomes my x value, so I go over to my 8, and I'm like, what is the value on the blue graph? So I go down, and I see it is -3. More of the same that's happening here. And I like to write it a little bit differently and just change the colors so it's easier to see. And so I'm evaluating G at -1 first, so that's 1. What is my y value? It is 2. That's what comes here. Now this becomes my x value, so I go over to 2. What is my value for y on the blue? And you see it is 1. For B, we have G of G, and we're evaluating at 3, so my x value is 3. I go, what is my y value here? I go down, it is -2. That's where this comes from. Now that becomes my x value. I go over to -2. What is my y value here? It is 0. And then finally, we're looking here, we're evaluating with f first when x is 4. So I go over to 4. What is my value for the y on the blue? I see it is 3. Now that 3 becomes my x value for the g function or the red function. So I go over to 3. And then what is the value here on this graph? It is -2. Here we're looking at finding slope and using the difference quotient for doing that. So setting this up is just a lot of substitution. It looks like a lot of work, but it isn't. I just showed a lot of steps for you. So this is what we're using here. And we're just simply doing exactly what that did. So in the earlier functions, when we were using composites to put things into it, as you can see in black here is just the original given function. And then we're going to be subtracting that given function. So you can see this is duplicated twice. The first time it's duplicated, we don't just use x, we use what we have in here is x plus h. So that is this part here. So we're evaluating this function, and I replace both of the x values with x plus h. Then I subtracted the original function, f of x. So you see that here. Next step is just simply to evaluate. Here we have to use the FOIL method because we have x plus h times x plus h, and we end up here. So that's what you see here. Here I distributed the 8x. Oh, I'm sorry, there's the 8. Here the 9 just comes down, and here I distributed the negative. In this next step, this is always going to happen if this is done correctly. Everything over here that you've just subtracted in the original function, all three of these things, or however many that are in there, will be eliminated. So as you can see, the -9 and 9 cancels, -8 and positive 8x cancels, 3x squared and -3x squared cancels, leaving us with this. And then we just simply divide or cancel out each h in each of those, and leaving us with this. So -6x plus 8 minus 3h. So we're going to repeat this with this particular function. So as you can see, it has been duplicated twice. We're subtracting the original function, 10 minus x squared. And here, we're just simply replacing the x with x plus h. We only have one x to replace here, and in the other one, we had 2. So that's why we have 2 of those in the top one, and here we just have 1. So here, once again, we need to square that in FOIL, so we end up with the same thing we had before. We need to distribute this negative, and we've already distributed here. Just like I said before, whatever you're subtracting here must cancel. And then whatever you're left with, you simply cancel out or divide by the h to give you your final solution. On this last one, we are looking at cost, revenue, and profit that is being made. And then we're graphing that function. And so looking at a cost function, so here it says we have a fixed cost. So this might be what you have to rent out the place for each month. And then we have it costs $15 to produce. So we have 15x plus 700 is going to tell us what we have to pay out in order to produce this. And then in our revenue, it goes from what we are using or what we is the cost for each item. So each item sold, we're going to bring in $40 per item. Then to get profits, we have to take the money we're taking in minus the money that came out of our pockets to produce it, and this gives us our profit. So those are our three equations there. And then D, it's asking for when we're going to have a profit. And so you set it equal to 0. This lets us know when we sell 28 items, we've made $0. So that means on the 29th one that we sell, we'll finally turn a profit. And then here you can see the graph here, and I just used our y-intercept. So when x is 0, we get negative 700 using this graph here. And then also our profit here, or 28. So I know that I had 28 here. And we see our slope, since these are going over by 2, our slope is 25. But if I'm going over 2, then I'm going up 50. So that's kind of what happened here. So up 50 over 2, up 50 over 2.